back. I'm here with another example on method of substitutions. Guys, look at example number 8 here. We have a ratio. So far we were looking at product of two functions. Now we have a ratio of two functions. Again, you would agree with me that we cannot directly evaluate or find the integral of this expression. So one is going to use we're going to use the method of substitution. Guys, in this case, you can see that both there's a radical x upstairs as well as downstairs. So we don't really have to think too hard. We can just simply set the u equals to the radical x because we don't have any choices here. So that kind of makes life easier sometimes when both are like almost similar. So of course there's a cosine with it as well, but as far as the x goes, it is both upstairs and downstairs we have a radical x. So we're going to start with step 1, letting u equals to radical x. So instead of radical x, that's fine, we can leave it like that, or we can write it as x to the power 1/2. So I think I would rather like to rewrite that as x to the power 1/2, because in the next step we have to write the derivative, and in order to write the derivative we want to have an exponent so that we can easily use the power rule. Okay, now step number 1 done. Step number 2 is taking the derivative du over dx. Guys, the derivative of this is going to be 1/2 and x to the power n minus 1, so that 1/2 minus 1 would be negative 1/2, right? And if I simplify this further, guys, it is going to be 1/2 radical x, because when I bring this downstairs, it would be 2 is already here, and this would the negative sign will change to a positive sign. It would be x to the power 1/2, and I can rewrite that x to the power 1/2 as radical x. Okay, so from here, guys, keep in mind we have to actually solve for dx. That is what the step 2 is. Step 2 actually has two subparts. One is evaluate the derivative, and the second one is you got to solve for the dx. Okay, so solving for dx simply means let me actually do the steps for that. So du over dx is 1/2 radical x, right? We're going to cross multiply. We're going to cross multiply across. That's what that simply means. So got dx equals to 2 radical x du. I'm going to put that in a box, and then of course I have this in the box as well. Okay, step 1, step 2 done. Then step 3 is bringing this all together back to the original function and substituting values. So guys, it is going to be integral. Then what do I have? I have cosine. Well, cosine will stay as cosine, but radical x is no more now radical x, because we want to change it to a different variable. So I'm going to use the variable u here. Okay, that's exactly what this step says. We got to substitute back, and then divided by radical x, we just leave it like this. And then because we cannot the radical x, well, here we can if you think to convert it back, like use u for it, you can, but let us wait and see, because most of the times these things cross out, right? If you have already seen these examples, or if you have worked on these examples, you already know that some things cross out. Okay, so let us see if things already cross out. So let us bring the dx piece. So it is 2 radical x du, right? Now guys, what happens? The radical x and radical x already crosses out, so we don't really have to worry about this. This is gone. This is simply integral, and then there is a 2 here. I can bring that 2 already outside, because that's what we do with the constants. And then there's a cosine of u and du. Okay, guys, even if so, I want to clarify some confusion. Even if you want to substitute this radical x by u, you can do that. That's u here. But then when you bring this back, then radical x can still be substituted by u, and the u's will cross out. So in both cases, it's going to cross out, and you're going to be left with just 2 cosine u du. You take out the 2 outside the integral sign, and you're only left with evaluating the integral of a cosine u. And to evaluate the integral of cosine u, you just have to either, if you remember it, that's good. If not, then you have to use the formula sheet. An integral of cosine function is simply sine function, sine u plus c, but of course the original function is in terms of x's, so we got to have the final answer as 2 sine of u. But what is u in terms of x? Radical x. So 2 radical x plus c. Guys, if you want to verify this answer, take the derivative of this, and you should get back this function right here, and that's how you could actually verify your answer. Okay, so that is example 8. Guys, I'm going to see you in my next video with another example number 9. Okay, till then.